Hi, everyone. My name is Catherine Au. I'm an environmental specialist with ICF, and today's webinar is radon testing and mitigation, specifically the ANSI ARST standards, along with a Q&A discussion. This is the second in a series of radon webinars hosted by HUD. The first one several weeks ago was Basics of Radon in Housing, and the recording and materials will be posted on the HUD Exchange. Those of you who are registered will get a notification when those materials are available. Again, today's webinar will also be recorded and posted in the coming weeks. And then there is a third webinar that will be on HUD's upcoming department-wide policy on radon, which is at a date to be determined. And at this moment, I'd like to hand it over to Glenn Schroeder for a quick update on that. And Glenn is from HUD's Office of Environment and Energy.
Thank you. Hello, everyone. As Catherine mentioned, my name is Glenn Schroeder. I'm the contamination subject matter expert here in OEE at HUD. I want to thank you all again for joining our second in a three-part webinar series all about addressing radon. We again this time had over 1,000 people registered for this webinar, which is very exciting. And I again want to thank all of you for being here and for your commitment to providing safe and sanitary housing as well. Again, just want to give a quick thank you and shout out to the National Radon Program Services at Kansas State University. As with the first webinar, staff from KSU will be here again as well to answer all your technical questions during the Q&A portion at the end. And as Catherine mentioned, we are in the process of developing a department-wide policy on addressing radon in the HUD environmental review process, which again would be the first time ever that HUD addresses residential radon exposure on a department-wide level. As mentioned, we won't be talking about that policy here today in this webinar. However, stay tuned. Our third webinar will be all about that policy and will occur a little while after that policy has been published so that folks have time to read it, digest it, and gather any questions they may have about implementation. And then that third webinar will be a chance for you to ask any of those questions that you have about implementation of that policy. At this time, that third webinar has not yet to be scheduled, but we do expect it to be scheduled and to occur within the next few months. So stay tuned for the HUD Exchange email list, and we'll send a notice out via that once that third webinar has been scheduled and that registration link is over. Thank you all again for being here today. I'll now hand it back over to Catherine and our partners at ICF to begin the webinar.
Great, thank you, Glenn, for that update. So outline of today's presentation is a brief review of what we mentioned last time, the radon basics, just to, a little recap, and then standards for radon testing, mitigation, and radon-resistant new construction, and then take questions that came in during registration and from the live audience. As Glenn mentioned, we are not talking about HUD policy on today's webinar. We are talking about industry standards. As with the first webinar, we'd like to get to know who you are. This webinar series, the intended audience is HUD grantees. So most of the choices are different types of major HUD grantees. So what type of organization do you represent? There should be a poll question come up, so choose the answer that best represents who you represent, whether that's city, county government, state government, public housing authority, tribe or tribally designated housing entity, or other. Okay, so a lot of other folks here. So I wonder if they're government or industry, but definitely a majority city, county governments, and a bunch of state governments too. So that's fascinating. Very great. Okay, so recap from last time. Some EPA infographics. Radon is a naturally occurring radioactive gas. The source is in the soil from the geology of the location. the radon gas can enter your home through the ground and affect indoor air quality. The radioactive decay products from radon get breathed into your lungs, and that radiation can damage your cell DNA and over time cause lung cancer. And the only way to know if your home has high levels of radon is to test. Here's an infographic showing or illustrating different pathways of entry of that soil radon into a home. So all the different red arrows are paths by which radon can enter your home, such as cracks in the foundation, radon in private well water, cavities around walls or gaps and different floors or between utility connections, things like that. How to test for radon. Last time we went over, there are short-term tests, long-term tests, and continuous radon monitors. Short-term and long-term tests can be bought commercially for $20 to $40, including the lab fee. If you buy them in bulk, you can even get it down to under $10 per test if you buy them in bulk from labs. Continuous radon monitors are professional devices that are much more expensive, upwards of $800, double or triple that, depending on the device and model. The household items or the household or layman monitors that you might be able to buy online for $100 to $200, those are not devices that are approved by the National Radon Safety Board or the National Radon Proficiency Program. And so the accuracy of those devices is questionable. And so you wouldn't really want to base your mitigation decisions on those lower cost digital devices. There are many different technologies for short-term tests and long-term tests, such as alpha track or charcoal canisters, electric ion chambers. They all have their pros and cons. There were a bunch of questions that came in on which ones are more accurate, which ones are better than others, which ones would you choose? And really, you just follow the manufacturer's instructions for operation. Some tests are, you have to operate for at least 5 to 7 days. Many of them can be affected by humidity and temperature extremes. So just follow the manufacturer instructions and follow the standards that we will go over in today's webinar, and then you will get a more accurate result. In terms of short-term and long-term tests, short-term tests can range from 2 to 90 days, and long-term tests are more than 90 days. So for a HUD grantee setting, more likely you would choose the short-term test or continuous radon monitors so that you're able to make mitigation decisions or know those levels sooner rather than later. What do the results mean? 0 to 2 picocuries per liter. You would just retest every few years. It's basically a normal background level. If you're between 2 to 4 picocuries per liter, you should consider fixing, because at that rate, especially above 2.7 picocuries per liter, is when you start seeing increased risks for lung cancer. The World Health Organization action level of 2.7 is not referenced in the national standards, so you don't need to go by that 2.7 number. It's just something to keep in mind. So you could consider fixing, but you're not required to. And then the EPA action level of 4.0, if you're above 4.0 picocuries per liter, then for health and safety purposes, you should mitigate the building. Certification bodies that certify testers, mitigators, list approved devices, provide training. 2 of them. One is not better than the other. You can do either. That's the National Radon Proficiency Program, or NRPP, and the National Radon Safety Board, NRSB. And then I've included links to a list of approved testing devices that they recommend. Last webinar, I went over the state radon fact sheets that are provided by Kansas State University's National Radon Services Program. Here is an example of a state radon report card, which is provided by the American Association of Radon Scientists and Technologists. So similar information, just Very short fact sheet, one page with some infographics, really useful on the bottom left, the statewide radon policies. So, does your state require credentialing to do testing or mitigation? Which standards are in effect? Do you need to notify or disclose to the home buyers or potential home buyers any radon test results, things like that? And you can see here from Minnesota, they basically have requirements for all of them except for school testing and school mitigation. Okay, another audience poll just to see if you guys got the most important thing from last webinar. Let's say you live in Savannah, Georgia, which is zone 3 on the EPA map of radon zones. Does this mean that your house will have low radon levels? Yes, so testing isn't necessary, or no, the only way to know is to test. Okay, so most of you got this one. Great. This is really the most important thing from the last webinar, is that the EPA maps of radon zones are not accurate to they're not accurate to an individual house level. They don't really tell you about your individual risk. For some counties or jurisdictions, there has been more research into the development of maps that are more based on soil types and soil uranium sources. And a couple of counties in California or maybe Utah, we saw some examples last time. So that might be better information that you could use, but definitely don't use the EPA radon maps because they're not really based on complete or updated data. And they're not also intended for use to determine individual sites. Okay, so moving on to today's content. First, industry standards. Industry has developed what we call these voluntary consensus-based standards. And those are standards that are developed using procedures that have a fair and open and transparent process so that anyone who's interested can have a voice and make sure that their expertise and concerns are heard. And yeah, so these are consensus-based. EPA does not have the authority to set radon standards, but there is a National Technology Transfer and Advancement Act, which directs the federal agencies to adopt these voluntary standards when possible. One example of voluntary standards that you might be familiar with are Energy Star standards. So just shout out to that. But today's focus will be the ANSI-ARST standards. ANSI is the American National Standards Institute, and they accredit standards. So they basically approve standards. And then ARST is the American Association of Radon Scientists and Technologists, and they're the ones who are putting together and developing these standards. So ARST develops them and ANSI accredits them. And the standards include for radon testing, mitigation, and radon-resistant new construction methods for multifamily homes and other large buildings, as well as for homes. Here's a breakdown of the official titles of these standards. So for single units, residential units, you have testing and mitigation. If you listen to other radon webinars or attend other training, you might hear people say MAH 2017 or 2019 or MAH 2013. So that just means they're referring to a specific standard for testing for radon. So you have testing, that's highlighted in measurement. So testing and mitigation for homes. You've got testing and mitigation for large buildings, and that includes any multifamily building, as well as non-residential building. They basically lumped them into one standard in the 2023 standards. They also have standards for radon-resistant new construction. So referenced here, you don't need to memorize them. These standards are all available online on the ARST website, and you can view and read them for free. If you want to download or print them, then you would pay a fee. Briefly mentioned, there are other standards out there, some legacy standards from EPA who have developed standards back in the 90s for testing mitigation and new construction, as well as ASTM E2121. But both of them, or the EPA and ASTM standards, have not been updated in over a decade. And since 2012, EPA has recommended the use of the NCR standards as opposed to the EPA standards. So I reference them here because several states still have these other standards as what the state requirements are. So if you are in one of those states, then you would need a copy of one of these standards, but otherwise the NCR standards are what's more widely adopted these days. Here's what the two standards look like for the testing ones. So single family on the left and multifamily and non-residential on the right. And they're mostly the same. The procedures are mostly the same, with a couple of additional considerations for multifamily, which I will go over. Okay, so testing. You test existing buildings. We've had several questions come in about, well, I've got undeveloped property. How do I test on vacant undeveloped land? The answer is you don't. I think last time Christina mentioned that you can test the land, but you'll get these really high testing results that will not be correlated with the indoor radon once you have a building built. So really, it's not practical to test vacant land or undeveloped land. You only test an existing building. When do you test? You can test any time of the year, even though summer tends to have lower radon levels than winter because of increased ventilation with windows and doors open more often. Through following the testing protocols, you can still test any time of the year. Just don't test during severe weather conditions if you're doing a short-term test, because changes in pressure differentials, low pressure systems, or wind gusts of more than 30 miles per hour, or heavy precipitation. There's all sorts of types of severe weather conditions, but those different events can affect the radon levels temporarily. So you might get a spike or dip in radon levels due to this severe weather event that really isn't representative of the average annual levels. So don't place a test when severe weather is afoot. And then what devices do you use? Which test kits would you use to test? Follow what your local jurisdiction requires. So check your state regulations and make sure that you're using one that's listed by a certification body or meets the NCR device performance standards. So, either what the state requires or use a test that's listed by something like NRPP or NRSB. And then there are two types of testing protocols. The first one is time-sensitive protocol. That's the one that's more commonly used. That's when decisions are needed in days or weeks. And you use two short-term tests side by side. And then you take the average result. Or you could just use a continuous monitor, so those digital devices with the hourly measurements, and then again, use that time average for mitigation decisions. There is an option in the standards to do an extended testing protocol where you start off with a single short-term test and then retest any areas that are above 4 picocuries per liter. And there are reasons that you might use that protocol, but best practice is probably to use a time-sensitive protocol. Where do you place these tests? Definitely in the lowest level of the home that is or could be occupied. So if you have a finished basement that maybe people sleep in or have an office in, where they really spend any time, or where it could be occupied, then you would want to test in the basement. One test, or for the time-sensitive protocol, you would just do two side-by-side tests. Additional locations would be necessary if you have a large home where that's covering more than 2,000 square feet footprint. If you have different foundation types, so for some reason the building had, one area with the basement, another area that had crawl space, or another area that was concrete slab, then all three of those different areas could have different radon levels. So you'd want to test different foundation types. And especially with larger buildings, if you have any areas that are heated or cooled using different systems, then, depending on what those systems are, you would definitely want to test those separate areas. For specific placement of the test within a room, you want to be at least 3 feet away from exterior windows and doors, at least 20 inches above the floor, at least 1 foot below the building, below the ceiling, at least 1 foot from the exterior wall, 4 to 8 inches away from the other tests. When you're doing the side-by-side test for the time-sensitive protocol, you want them to be close together so that you're basically getting the same reading, but it improves the accuracy when you have 2 of them, right? But they should be 4 to 8 inches apart, not in separate rooms. You also want to put the test somewhere where it won't be disturbed, by children or pets, where someone could easily knock them over. Here's a graphic of what that looks like. And basically you want to mimic an airspace that people are going to breathe in, other than babies crawling on the floor, you're not really going to be breathing on the floor or right below the ceiling. And you want to stay away from anything that could interfere with the test results, such as drafts from windows, things like that. Specific areas not to place the test would be in closets or crawl spaces. No one's occupying those spaces for any appreciable amount of time, so those test results wouldn't really mean anything. Not in direct sunlight or near heating sources, because as I mentioned earlier, the technology of the tests could get affected by different temperature extremes or humidity conditions. So it could actually damage the test if you put it in direct sunlight, or at least render the reading less accurate. Not near any drafts from fans or vents, because that could just blow air across and, again, artificially lower those radon levels. Not in enclosed humid areas, such as bathrooms, laundry rooms, or isolated kitchens, unless they're open to another room that's occupied for more than 4 hours a day. Humid areas is important to, they're important to avoid because some of the tests are sensitive to humidity. So again, you might get a false high or low reading if your test is exposed to overly humid areas. Also, you want to avoid natural stone objects, such as granite countertops, because the stone itself could be a source of radon. I mean, it's not going to be a big source of radon, but being a source of radon would also affect your test, and that might give you an artificially high reading that's not representative of your overall conditions. And then really important is implementing closed building conditions. This applies to short-term tests, which are between 2 to 90 days. So basically you want, for the whole duration of the test, you want to keep windows and doors closed. You can still do normal entry and exit, you can't just lock yourself in the house all day, but you want to keep them closed to, mimic like winter conditions, basically. Set heating and cooling to 65 to 80 degrees. Set any ventilation with outdoor air to the lowest seasonal level. Avoid excessive operation of bathroom fans or exhaust fans, things like that. I mean, you can use things normally, definitely, put on the bathroom fan for 15 minutes, 30 minutes, that's fine. Clothes dryers, run a load of laundry, that's fine, but you wouldn't want to run any of these for hours and hours on end during the testing, because that's not really realistic for your normal conditions. Do not operate a fireplace or whole house fan, because that will also affect the air circulation or air ventilation throughout the building. If your test duration is going to be less than 72 hours, you want to start these closed building conditions 12 hours before placing the test. And that's because it takes at least 12 hours after closing the building envelope in that way for the indoor radon levels to stabilize. So yeah, make sure, if you're going to test for 65, 70 hours, it's just really good practice to make sure you close all the windows and implement the closed building conditions 12 hours before putting the tests in deployment. If you're testing a home or a building that's newly constructed or a building that's undergoing renovations, repairs, there are additional requirements for when you conduct the testing. Basically, you wouldn't want to test a building that's still under construction or that's only partially finished. You want to make sure that the building envelope you're testing is fully there and representative of what the actual conditions will be when there are occupants. Things to keep in mind, again, those closed building conditions are really important 12 hours prior to testing if it's a short under 72 hours test, but otherwise throughout the test period, whether it's 3 days or 5 or 7 days. Notify your staff and tenants. If you're going to do radon testing, let them know, hey, we are going to conduct radon testing on these days. Please note that we may need to access your unit. There's no cause for alarm. We're just doing a routine test. We'll need access to your unit. We'll have to put this test here so that they know what it is. They're not going to throw it away or move it to a drawer or someplace that it's not supposed to be. Selecting testing locations, becoming familiar with all the slides before about where you should place your tests. Make sure you give the person testing doing the tests, make sure they have access to the spaces. And then whoever manages or owns the property should also sign a non-interference agreement, basically agreeing to do their best to maintain these closed building conditions and not tampering with the tests, such as opening the windows or putting it in a closet or something else to artificially lower those results. Additional considerations for multifamily buildings. You need to test all ground contact units and occupied non-residential rooms. And then on each upper level floor, test at least 10% of the units. Don't place tests in hallways, closets, or bathrooms. And then if you have a building with large rooms, every 2,000 square foot for any of those large rooms, if you have a big common space or open floor arrangement. Really important, the tests must be conducted on the same days. If you have a multifamily building or a non-residential building and you need 10 testing locations for it, you don't come back, don't do one test on one day, that's going to last several days, and you don't do it in sequence, you do everything at the same time. And so that means that you might need dozens or hundreds of test kits if you have really large buildings that you're managing. And so what does that mean for your programs? How do you implement this? Folks have been saying that it costs hundreds of dollars to hire a radon mitigation radon testing professional, and all your results have been coming out low. So why can you do this yourself? So one strategy you could consider is training your own staff in testing. There are many courses available and listed on the NRPP and NRSB websites. And I have those links at the back of the presentation. Just make sure you follow the state requirements for credentialing, whether some states don't have credentialing requirements, so anyone can test, but other states, you have to be certified, either, some states have a state certification program, and other states require that you get the either NRPP or NSRB credentialing. So make sure that you're going to follow the state requirements. And then at any rate, know the logistics required. So, read those standards, study the slides from before, and really know what you're doing and implement best practices. So if you are doing your own tests, then at least you know that your results are going to be accurate and that you're using industry practices and industry standards. In terms of test devices, again, you can buy kits directly from laboratories in bulk. And if you do that, then you can actually save a lot of money and purchase kits. If you're buying hundreds of them at a time, you can purchase them for probably under $10, and that includes the laboratory fee. If you're more of a program that does, homeowner rehab, or you're testing one unit at any given time, then you could consider continuous radon monitors. Again, those cost at least $800. You probably need training on how to operate those devices. The good thing is they're reusable and they're pretty accurate. The bad news is, besides the cost, they also need to be calibrated every year to make sure that they're still giving accurate readings. And so there are additional operations and maintenance costs associated with those continuous radon monitors. All right, so let's do a case study and look at some test results from this real example. There was a 3-story historic building proposed for redevelopment into mixed-use commercial and residential. The second and third floors are currently vacant, so they wanted to rehab it. And then the first floor is currently occupied commercial. For the HUD environmental review, this building was tested for radon as well as for other things. And here is the test report, which was 3 pages. The basement came out to 8.7 picocuries per liter. The first floor came out to 4.1 picocuries per liter. And then the second floor came out to 1.2 picocuries per liter. We did get questions on what's supposed to be in a radon test report or a radon report. And I'm not sure if you're referencing just like what according to the standards or according to best practices versus what's required by HUD programs such as the MAP guide. So I'm only talking about kind of industry best practices. I'm not talking about HUD requirements here, but basically everything you see here should be included in your test results. So which company, which I didn't list here, but which company, which laboratory, what type of test was used, the method, the location, the address, and then the start and end times for the test. That's pretty standard for what you'll see in a radon report. Okay, so I have excerpts of the report pasted here for your reference, but the testing procedure did not follow ANSI standards for which of the following: test duration, test location, test type, or closed building conditions. And the hint is all of the information that you need to answer this question is contained in the excerpts that I've included from the report. All right, so the majority of folks said, or I guess the more people said testing location, but equal amounts of folks said test duration, test type, or closed building conditions. So let's break this down. I guess from the bottom, closed building conditions, you see where it says closed house, yes, closed house, yes. So I'm assuming that means they did maintain closed building conditions. So that's fine. Test type, activated charcoal, short term. There was the serial number, that's fine. Test duration, for 2 of the tests, it was 70 hours. And for the second floor one, it was 95 hours. I'm not sure why they did that discrepancy, but that's more than 2 days, which is the requirement for the standard. And for this type of test, activated charcoal, that's about 3 days. So, okay, I might look into, okay, did they follow manufacturer instructions? But that's more based on from kit to kit. For what ANSI specifies, there is no minimum beyond two days. So that's actually okay. Test location is the red flag. Test location for the second floor, they did the bathroom. And for the first floor, they tested the rear storage. And as I mentioned before, places you do not want to place the test are places that are not occupied by people the majority of the day. And then places with high humidity levels are also locations to avoid. So here, because the unit is vacant, so no, I could give it a pass for putting it in the bathroom, in the sense that, okay, maybe the high humidity levels wouldn't apply here because no one's using the bathroom. Okay, that's fine. But in terms of the configuration of the house, well, the bathroom and rear storage still aren't places that are representative of where people would occupy. So I do question why the testers chose those locations. At any rate, if we accept the test results as is, what are the next steps for this project? Look into mitigation options. Don't look into mitigation options because the second floor was fine and that's where residential is going. Don't mitigate because no one's occupying the basement and that's where we got that 8.7 level, or cancel the project. Okay, so most of you said look into mitigation options. So that's 88% of you, and that's correct. Even though the second floor had a low result, the first floor, which is where the commercial establishments are going to be, that had a high level. That was 4.1 picocures per liter, and that is above the EPA action level. So whatever staff is operating those commercial establishments, like they're getting exposed to high levels of radon, that could be a risk. The basement, yeah, we don't really care about the basement if it's not an occupied space. But basically, you should look into mitigation because the first floor had high levels. If the mitigation options aren't feasible or you're in an area where you absolutely cannot find anyone to mitigate, then okay, maybe you would cancel the project. Before you hire a contractor, you should check what your state credentialing requirements are so you know what to expect and what to ask for. It's like, oh, okay, my state has its own certification program, or my state expects any professional to be certified in NRPP or by the NSRB or NRSB. Then so you know what the state requirements are, and then check for the contractor's credentialing. What are they credentialed in? Are they certified by the national organizations or by the state? And then, when you're communicating with the contractors, confirm, okay, are you going to use test methods that follow the ANSI ARST standards so that we know what to expect? Okay, so that's an overview of the testing standards. Now we'll give a very high level overview of what mitigation and radon-resistant new construction look like. There is one technical term that I'll have to use, but I'll try to keep everything to a minimum. And this is what the mitigation standards look like for ANSI ARST. Okay, so the main term here is active soil depressurization. The radon comes from a soil source, and so it's really that's where we need to focus our efforts on for removing any radon. Different components of the system. You have your suction of subslab soil. So basically you kind of preempt the radon from entering the home by suctioning the radon from the soil beneath the home through a pipe. And that's going to be like a 3 to 4 inch PVC pipe. There's going to be an inline fan on the outside, and the pipe will vent outside away from areas that would be occupied by people. The system will have a performance indicator to let you know that the fan is still working, and labeling to show that this is a radon mitigation system as opposed to any other utility pipe. It should come with operating instructions, and after it gets installed, there's also post-mitigation testing that's necessary to make sure that your mitigation is effective and mitigating below 4.0 picocuries per liter. Here's what that might look like for buildings with concrete foundations. So the pipe has this opening at the bottom to a gas permeable layer underneath the concrete slab. And then there's a fan at the very top, and then it just, suctions that air up and out. For buildings with basements, basically looks like the same thing, except you're going beneath the basement floor and not the concrete slab, but same thing. You've got a gas permeable layer that the pipe opens out into. There's a fan that suctions the air up, and that radon goes out, up and out. There are other components to mitigation that are complementary to the active soil depressurization systems. So you have sealing and caulking. In this photo or in this infographic on the left, you can see, all the cracks in the basement and like all the red arrows showing potential exposure routes. So in addition to having the pipe, you'd want to caulk and seal all those areas so that the gas doesn't get in through there. You could also use membranes such as vapor barriers to, again, separate the soil air from getting into the building. But both of these strategies, sealing and caulking and membranes, are not standalone strategies. They have to be used along with the active soil depressurization system in order to be effective. Using these alone is not effective by themselves. There are methods that are non-active soil depressurization, might have to do with the ventilation systems, soil dilution, air dilution. There are a lot of other ways to mitigate, but that's specific to the building type, the ventilation type, and more applicable to large buildings, so multifamily or non-residential buildings. Homes, you're most of the time going to be using the active soil depressurization that we mentioned in the previous slides. It's for these large buildings that have their own nuances that, okay, you might be able to utilize other types of mitigation, but you should definitely consult a radon mitigation professional that has expertise in large buildings. Most of the market out there works only with single family homes, so make sure you find someone who knows about systems, installing systems in large buildings. Okay, so that was mitigation in a nutshell. Radon resistant new construction is very similar, so hopefully it'll help explain the mitigation if that wasn't clear enough. So very similar, from bottom up, you have a gas permeable layer. So that's going to be typically 4 inches, at least 4 inches of gravel beneath the home. Plastic sheeting, so that membrane to separate, like the vapor barrier to separate the radon soil gas or the soil radon gas from entering the home. You're going to seal and caulk all those areas that the gas could leak up into. So basically very similar to mitigation. You're going to get the vent pipe. And then 5 is a junction box in the attic. This is a passive ventilation system, which means there's no fan, but they're not always 100% effective in reducing radon to under 4 picocuries per liter. So there's always that option to install a fan to make it an active system. And so in the attic, you would also install a junction box. Here's just another view of that. These illustrations don't show it well, but the major difference between the passive systems that you install with new construction versus the retrofit mitigation options is that the new construction systems are in the interior of the home. So they're away from, at least several feet away from the exterior walls. The photo here sort of shows it in the interior, but still shows it too close to the edge of the home. So it's like, it looks like it's right next to the wall, but it's actually much more interior, closer to the center of the building. Whereas the retrofit mitigation systems are on the outside of the homes typically. And so how does that work if you don't have a fan? It basically utilizes the physics principles of the stack effect that Paul mentioned last time, where you have the house or the building indoor it's warming the air in the pipe. So let's say room temperature, let's say it's causing the air in the pipe to be 70 degrees and warm air rises versus the air that's at the bottom in the soil that's closer to 55 degrees, it's in the ground and the soil is pretty cool. And so that warm air rises out and pulls cold air up. And so there's a sort of continuous rise of that air. And so that's a passive system. It's not as effective as the active systems, but it's good practice to have in there because that still lowers your radon levels. And then you always have the option to install a fan. And overall, it will be much cheaper to have this in place already than to try to install one after the fact. Okay, so that was new construction in a nutshell. There are a couple of specifications and requirements for these systems that I want you guys to pay special attention to, especially when you're ordering a mitigation system and consulting with a professional and they give you a proposal for what the system is going to look like. Here are a few things to watch out for in case the professionals aren't following them. So these are really, even if you're not following the standards, these are best practices, but definitely things that are in the standards. The first one is the exhaust points. The radon gas gets pulled from the soil up and out into the air. So that exhaust point where that gas comes out, that must be located outdoors. The whole point of having a system is to keep the radon from going indoors. So make sure that you're venting that gas outside. It should be at least, the opening point should be at least 10 feet above grade. It should point upward. You can have it 45 degrees upward, and the new 2023 standards allow for 90 degrees if you're at least 20 feet above grade. But in general, you want it blowing upward. It should be 10 feet horizontally from any windows, at least 4 feet from any windows, and then, let's see, that's 10 feet sideways, 10 feet above windows, and also 10 feet away from any balconies or decks. Otherwise, when people hang out outside, then they might get exposed to that gas. So you want to make sure it's venting in a location that's not near people. It should be above the roof or 20 feet above grade if it's beneath the roof. At least 6 feet above the roof if it's on the side of the building, or 18 inches for flat roofs. I didn't get into all of the requirements, but those are the basic ones. And then for the fan, location. It can be in the attic, outside, or in a garage. When you're considering the location, think about, well, it's a fan, it's operating, there's going to be some level of vibration and noise caused by the fan and the exhaust air. So, make sure it's installed in a place that's not going to be disturbing the occupants. Do not install it in or beneath conditioned or occupiable spaces. The photo on the left-hand side shows a mitigation system in a basement utility room. That's beneath an occupiable space. That's really not good. It's also very close to a lot of electrical wiring and other utility pipes. So don't do that. If I really want to pick on it, it's also venting. I can't see exactly where the exhaust vent is, but I can't tell if it's actually goes up or if it just vents basically at ground level, which would also be wrong. So don't do what's in the left photo. Right-hand side, much more standard. Outside in the back or in a space where it's not near people. The system should also have an alert or notification system in case the fan fails. That should be audible, or it should be an audible or visual alert, or a telemetric system that sends you a message if the fan goes out. And it should be powered separately from the fan. So if electricity to the fan gets cut off, you don't want that alert system to be on the same electricity source. Visual alert is very common, and that's going to be in the form of a manometer, which is that U-shaped tube you see in these 3 photos of different colored liquids. One end of the tube opens out to the air, and then the other side opens into the pipe. And the side that connects the pipe should be higher than the part that connects to the outside. So in all cases, the levels should be uneven. And if it's uneven, then the fan is working. If it's level, so that the pressure is the same on both sides, then the fan has stopped working and you need to contact the mitigation professional. Important note, you see these numbers 0, 1, 2, 3, 4. That's not the radon level. This is not a radon test. It does not tell you how much radon there is. It's just showing you if the fan is working. You'll also want to get into the habit of checking this every quarter or every 3 months to make sure that it's working. Ongoing maintenance of other components. All of your system parts should be clearly labeled, especially any that are inside the home. You see here it says radon fan, or this is a component of a radon system. Do not turn off or disconnect. And so people know exactly what these are for, and they don't accidentally, dismantle or change the system. I'm going to say, oh, what is this pipe doing here? And the labels should also include the contact information for the contractor or building manager. And you don't see it in these photos here, but below where I cut off the labels, there are the name and the phone numbers for the mitigation professionals there. Post-mitigation testing. So again, after you install these systems, don't just assume that you're good, that it's working. You want to test the system after 24 hours after installation, but no more than 30 days. Contractor responsibility. So this is what you as the HUD client should expect from the folks you're hiring to do this mitigation. The contractor is going to provide you with a proposal of how they're going to mitigate and what the design is. That should include an estimate of total ownership costs. So not just parts and labor for this one-time installation, but also over the life of the system based on current electricity rates. And then any future inspections or maintenance, parts replacements, like what's the total ownership cost going to be? They should notify you of the need to ventilate work areas when they're doing sealing and caulking. The sealants and caulking material tend to have harmful vapors until they're dry. So you want to make sure that they're aware to let you know and to let everyone else know to keep those areas highly ventilated while work is in progress, so that no one gets sick from exposure to the volatile organic compounds in these sealants. They should also be verifying through a visual inspection that, okay, we've installed it, this system is working. And then finally, they'll prepare to you this binder or information package. If you're a home or for large buildings, it'll be called an OM&M manual. So that's operations, monitoring, and maintenance manual. Both of them contain the same information. They're just called different things in the standards. And so that should include all of the testing results, testing locations, maybe the floor plan or diagrams of the building, specifications for the mitigation design and mitigation system, ongoing maintenance needs and instructions for how to inspect and what to do. And so you have basically this instruction manual for future reference, with staff turnover or, 10 years later, or, the fan stops working or radon levels get high again, you have this manual to kind of know, okay, this is what we have so far and this is what was done. What do we do next? And then you as the HUD grantee have responsibilities to provide the contractor with construction drawings and other information about the building layout and foundation materials. Like, don't expect them to just know everything. You should give them a diagram of the layout and let them know, okay, these were the architect drawings, this is what the building, how the design is. And as much as you can, provide that information to them so that they don't need to figure it out themselves. Save time and costs. Again, very important, notify staff, tenants, and anyone else entering and leaving the building about testing, mitigation, and any construction work, so that they know what's going on, so that don't interfere or that they don't freak out. Oh no, I've got high radon levels. Just, let them know what's happening. And then maintaining this OM&M manual, so that, people know what's going on and future staff know where to find that information. Some additional considerations when mitigating for multifamily or non-residential buildings. Again, there are methods that are not based on that active soil depressurization, but definitely consult with a mitigation professional who knows what they're doing. For that OM&M plan, it includes instructions to conduct a quarterly inspection to verify that the mitigation is still working. I know folks on the last webinar asked, how do I know that this is still working? Like, is this going to still work after 10 years? Well, in the OM&M plan, there are instructions to check, is it still working, in terms of, is the fan still operating? But also, you still need to test. Just because you have a mitigation system doesn't mean that you're good. You still want to test to make sure that things haven't changed. So when do we test? Every 2 to 5 years. For units or buildings or areas of the building that were mitigated, you would test every 2 years. If the levels were always low, it came out to 1.3 picocuries per liter, okay, great, test again in 5 years. Make sure you follow state requirements in case your state has more stringent requirements. You should also retest anytime you have new additions or do any rehab work on the building, major changes in heating ventilation systems or building envelope. If you newly finish an area or there's a newly occupied space, things outside the building, if you have earthquakes or new sinkholes, fracking or blasting, that might affect the geology a little bit, but more so it could damage the home or have more cracks in the foundation and have more pathways of exposure for that radon in the soil. So you want to retest if any of those things happen. Or if there's a change to the mitigation system. Again, you want to verify that those changes make the system still effective. Okay, now last audience poll, knowledge check. What's wrong with the vent pipes in this picture? I know it's not the best picture, you can't see them that well, but there is one on the left and one on the right. This building is a laboratory space, a rented laboratory space. It has 4 pipes, you can't see the other 2, but here are 2 of them. It's a flat roof. What's wrong with it? Okay. Half of the participants, majority of you, said angle of the exhaust pipe. Some of you said distance above the roof, and some of you said location of the fan. Distance between pipes, that we didn't even discuss that. So that is not a factor. Location of the fan, it's outdoors, so at least from a brief reading of the standards, it's fine. Distance above the roof, if you're on a flat roof, it should be at least 18 inches. And that looks to be at least 2 or 3 feet. So yeah, the correct answer is B, angle of the exhaust pipe. As I said earlier, it should be upward. It can be angled at 45 degrees, but it must be 45 degrees upward. Or for the new standard, the 2023 standard, which is available, but it comes into effect in December of this year. You can have 90 degrees if it's at least 20 feet above grade. This one, actually, that's downward, which is very problematic. My friend works at this lab and was doing electrical work on the roof for several hours, and he passed by the vent several times. And so he asked me, he's like, oh, I walked by that air a bunch of times. Is that going to be increased risk? I'm like, That's not great that you're exposed to that. Hopefully it won't give him lifetime damage. And then the other thing is having the angle that way, the water vapor can collect on the neck of the vent and create humid conditions that attract bats. So not a good design. And then finally, we had several questions from folks of, can I do this myself? Can I do this in-house? Multiple parts to this answer. First, I would say check your state requirements for radon mitigation certification. Does your state require certification or some type of credentialing to do radon mitigation? If so, then make sure whoever is doing your mitigation has that credentialing. If not, then okay, great. Next thing. Make sure you follow local building codes and obtain any necessary permits. For the installation of the fan, it's very common that you will need to have an electrical permit. So make sure you apply for that. And in any case, get trained. There are manuals out there or PDF documents or step-by-step guides that are informal that say, first drill a hole and then have a pipe. And like you can find brochures that tell you how to do this, but it's always good to get training to as high a professional level as you can, especially if you need to have that certification, and even if not, so that you can avoid pitfalls and mistakes that can render your system ineffective and basically a waste of money. Okay, some resources that we mentioned. Once these materials are posted online, then you can just click on these links to the ARST radon standards, the ARST state radon report cards that I mentioned today, the Kansas State University National Radon Program Services. There's also a link to the current status of what standards each state has adopted. Some states don't have standards at all. And then some other states, most of them reference the ANSI ARST, but a couple of them reference EPA or ASTM. So there's a document that KSU has compiled, so you can look at that homepage of the different certification bodies. And then if you're interested in getting trained, there are courses for testing and mitigation from both that are approved by both the National Radon Safety Board and the National Radon Proficiency Program. So if you want to go that certification credentialing route, then there's a whole list of courses that you can pick and choose from. Usually at least 8, probably 16 hours for testing, at least 16 hours, several $100s. I'm not sure how long the testing courses, the mitigation courses are. Okay, well, thanks for bearing with me for that. And now we will bring on our KSU folks, Brian and Christina, to answer any questions you might have had from the presentation. So I'll give them a moment to unmute and show themselves. And yeah, let me start with the live questions this time. First one, let's say, Brian, do architects or builders consider radon for new development projects?
We obviously want them to. There are a number of states that have managed to adopt the passive radon requirements into their statewide building codes in one form or another, but it's definitely a minority in the states that do not have statewide building codes. It's a home rule situation. So you have to kind of look at the jurisdictions to see if they've internally adopted what is called the Appendix F of the residential building code, which is the specifications for a passive system in the IRC. So the short answer is check your regulations, but we definitely recommend it in the entirety of the country. Just, you're always better off building passive and then activating. This will, if the property is still elevated, this is still going to save you money in the long term.
Great, thanks. So check your state first and then actually ask the architect, you can always bring it up and have them include it. And then Christina, testing in the summer months, good or bad idea?
Yes and no. So if we're talking about a single family residential type structure, we want you to test. And if testing in the summer is when you can test, as long as you have those closed building conditions met for 12 hours before you do your short-term test, then that is representative of your long-term exposure. In a multifamily or a school or an occupied large building sort of situation, what we want to do is test in a representative situation. So if it's not used in the summer or it's not used in the winter and there's nobody there and the HVAC setbacks are different, we don't want to test during a non-typical HVAC setback system. So for example, in a school or a daycare, you want to test during the week, Monday to Friday, because that's when the kids are there, that's when the teachers are there, that's when they come in, open the building, set the HVAC to a comfortable temperature, etc. And that's typically not going to be in the summer, depending on the program. So it depends. A lot of answers in radon depends, but we want you to test. So if that's when you can test and it's a single family structure, test it. And then if you get really low numbers, then we recommend that you test again in the winter season to see if there's some variation that you didn't account for in that summer test. If it's high, it's high.
Yeah, great. Thanks for that, Christina. And then Brian, let's say you have a duplex, both on a basement, you test both units or only one. And if one of them has high radon, do you do 2 mitigation systems or can you get away with only doing one?
Depends on how the builder put the building together. If we're sharing a common basement on a smallish slab that has maybe 2 separate units on the first floor, likely one mitigation system is going to be sufficient. But if we're dealing with an actual soil contact slab that's 2,000 square foot or larger, there's probably a weight-bearing footer in the middle of that slab, which would create the need in most likelihood of needing a system on each half of the building.
Okay, and then testing, I'm assuming you'd have to, for the standards, you have to test both units if they're ground contact. What if they're stacked on top of each other? If it's like a 2-floor?
A stacked duplex, we would probably treat it just like we would a single family and start on the first floor.
Okay. And then Christina, let's see, I guess I did answer this one already, but let's go to a question from earlier in the registration. Why, let's see, in some cases, or why is it allowed for testing and mitigation to be done by the same company?
So, I mean, part of it is functional, right? There are parts of the country where you don't have professionals of both groups separate so that you can have a different person do the testing from the mitigation. But the other side of it is that when they are certified individuals, and we're of course always talking about finding a certified individual if you can, they have agreed to be bound by ethical methods, right? You are supposed to not be thumbing the scales because you're supposed to have agreed to do that. And there's always a bad apple, but most people don't, right? In the context of mitigation, if you're putting the mitigation system in, there is no way for you to know whether it's working without running a test. And yes, ideally, someone else should run that test. And there are certainly mitigation companies out there who have relationships with measurement companies in order for those folks to do their follow-up testing so that they know whether or not the system is functioning. But if they are certified as a measurement professional and also certified as a mitigation professional, there shouldn't be a concern for them doing that work. They're there to do the work per those certification requirements and the ethics involved in those.
So find an ethical company. So related question basically answered is you can use the same company, you don't have to. If you have the luxury of or hiring different ones, you can, but a lot of places, more rural places, you might not have too many choices and options. So you might need to have them testing and mitigation performed by the same company.
And Along with that, there are at least one state that does require it be separate companies. So I can't think off the top of my head what it is. So the state rules always apply. So if you have a state rule that requires that it be separate individuals, then you have to meet those requirements. That's the state law.
Okay. And then let's see. How long does a test have to be in place before it creates results from the presentation? At least 2 to 7 days, but definitely follow the manufacturer instructions, because depending on the type of test you're using, which technology it is, the electric ion versus alpha tracker versus different charcoal tests, there are minimum requirements. So definitely check. Could be as low as 2 days if you're doing a continuous monitor, but more likely it'll be 3 to 5 to 7 days. Would that be accurate?
Can I add a quick note to that? We want 24-hour increments, right? So if you start at 8 a.m., you end at 8 a.m. because we want complete day-night cycles on our exposures.
Okay. And let's see. I guess for Brian again, do you have a list of labs that sell test kits or analyze test results that can be shared?
We always refer people back either to the state or to the national certification bodies, and pretty much both of the national certification bodies are referencing NRPP's approved device list. So if you go to nrpp.info and go to their devices, there's a list of certified laboratories, there's a list of certified devices.
Okay, yes, so there is a website that's not through us, but through the certification bodies where they have a list of approved labs. Okay.
I think I included that in the, I think I put those links in the FAQ that I responded to you for.
Okay, perfect. And Christina, what is the period of post-mitigation testing?
I assume this is a question about how long after the mitigation system is installed do we need to test, or within what period of time, or?
I'm not sure, because I did say it was 24 hours to 30 days.
Which is my answer. So it is, you have to wait at least 24 hours. I think there have been a handful of studies in single family settings, which indicate that 48 hours, by 48 hours, whatever is going to have changed in the house system that would impact a radon mitigation system's ability to be effective will have happened. So, but the standard says no sooner than 24 hours. You've got to wait at least 24 hours from the time you turn it on, and no later than 30 days, because we don't need to wait a long time. We just need the system on and running and then for the levels to resettle. So, and then it's the same short-term test that you did when you were testing on the front end. So the test period then with the continuous radon monitor is at least 48 hours of sample testing, or 3 to 5 to 7 days, depending on how your short-term kit is that you're using on the follow-up side.
So basically the protocol or procedure would be the same as the pre-mitigation testing.
Yes, it's identical, complete with the closed house conditions and the whole jam.
Okay.
Large building clearance testing is a little bit more complicated than that, but I would refer you to the large building mitigation standard for that instruction.
Okay. And then Brian, do lobbies, community kitchens and spaces and community buildings have to be tested?
So if we're doing, let's use the example of a residential care facility. If we're doing a residential care facility where, the residents are all in their individual units, we test all of the ground contact units and then 10% of the units on each additional floor by standard. But we also, in those situations, always include all commonly occupied space. So that would include the cafeteria, that would include the kitchen, that would include any office or medical space. Same thing applies for, say, a mixed use residential structure where we've maybe got offices and retail on the first floor and then residential on the preceding floors above that. We would test the entirety of the first floor as per the standard, and then additional testing on the residential units per the standard going up. So the short answer is we always include all of the commonly occupied common space.
Okay. And let's see. A lot of these questions are similar, or we've already gone over them. Okay, there are a bunch of these. Okay. Okay, here specifically for Brian, what is the definition of a large building?
Well, basically, from a multifamily perspective, HUD's definition is any building, any single building with 5 or more living units within it. Okay, that will vary from state to state. I believe New Jersey is 3. So again, always check your state definitions. But from a non-residential standpoint, if it's a commercial space, we consider it large building.
Okay, and then for Christina, how does this, I'm assuming it's mitigation, how does this affect installed engineered barriers that are installed for remediation of other contaminants? I'm assuming they're referring to maybe like a vapor barrier for vapor intrusion for other soil contaminants.
I don't know that I have the skill set to answer that, so perhaps Brian can help me out.
So this is complicated. I'll make this as simple as I can. The mitigation systems for radon look similar in many cases to what we do to mitigate other chemicals of concern, or COCs, which is what we would typically be looking at in a VI or vapor intrusion situation. The problem is that how those systems have to operate are a little bit different. So the short answer is, do not assume that a radon system will also be a VI system, although that will sometimes inadvertently be the case. The more complicated answer, feel free to call me on my phone number, and I will happily try to step you through that.
Okay. And then Christina, what are solutions in very rural areas that do not have large numbers of engineers or contractors?
I live in one of those places, and the answer is you're always going to have to meet your state requirements. So if you live rurally in a state that requires certified individuals, somebody is going to have to be certified. You're either going to have someone in-house go through the certification process and get that certificate from the state to do that. Or you're going to have to hire somebody who's going to travel to your location to do that and holds that certification for your state level. For the HUD funded projects, again, separate from the policy that we're going to talk about at some time in the future, those also require that you hold an NRPP or NRSB certification. So you have to meet those requirements. Somebody's got to have that information. And what that means is that someone has to be trained, and you've got to be trained on the single family side, because that's our entry level training. It gives you the entry information about buildings and building science that you need to do it. And then if it is a multifamily structure as defined by HUD, or it is a commercial structure, or it's a school or a daycare, then you will then need the multifamily large building training so that you can understand the significant differences between that process. It can all be the same people. Certainly your testing side, and I don't know what the policy will be because the policy is not out yet, but it may be that you can have in-house people go through the training and do the testing. That's a little more achievable. It's certainly how we approach it in several states that have schools testing requirements, is that the state has an exception for in-house testing. On the mitigation side, you really need a professional who ticks those boxes and has had that training. It doesn't mean that your person isn't able to do that. You may have an in-house person who can do that work once they have had the training, but they've got to have the training to get there.
Mm-hmm. And that basically also answers the question about what we're talking about with in-house mitigation. Is you can do in-house mitigation, but definitely follow your state requirements and know what you're doing and get trained as much as you can. And then Brian, I didn't get to emphasize this in the presentation. So 2 related questions. Is ventilation the best way to mitigate? And can you just crack a window?
So the short answer is no and no. To be quite honest, even in large building situations, active soil depressurization is probably, from a long-term cost of operation and effectiveness of radon control, still likely to be the best option. It's certainly the best option for single-family residences, for duplexes, for row house situations, and even probably for most actual up-down multifamily, where we're still primarily dealing with a soil gas entry problem at the ground level. Now, if we're dealing with large commercial buildings that have shared HVAC systems, it is sometimes possible to do ventilation approaches where we tweak the amount of generally income or intake air from the outside to act to both pressurize the building to slow radon intrusion and dilute the radon, the radon issues inside the building. But that's simply not going to be functional in a multifamily structure where every unit has its own HVAC system. So the ventilation approach is also still generally going to be the more expensive operational approach as well. And it has some back-end OM&M management issues associated with it that go beyond the scope of this talk. So ASD first, unless ASD is either contraindicated or you do ASD, it's not quite enough, then we might pair ASD with ventilation. But just cracking a window, not going to fix your problem.
Mm-hmm. And then Christina, should we mitigate if the basement had high levels, but the rest of the unit was okay?
I mean, that is the EPA's recommendation that we test again in a single family situation. If you test the lowest level of the home and it's high, then you should reduce it. It will reduce those levels across the board. In a multifamily or unit situation, it can be different depending again on how we heat and cool the building and what the best approach to mitigating that system is. If so on the one hand, if your basement is high, fixing it may fix all the rest of the building that you might need in the future. On the other hand, if you've tested a storage basement in the multifamily unit, you weren't necessarily testing the storage unit unless someone was using it per the standards. So every situation is going to come back at looking at the building as a whole and the process and use of those structures. But from the single family side, in a transaction, real estate type transaction, if your basement is low or your basement is high, you fix the structure because you don't know what the next person is going to be doing. Outside of that, it becomes a more situationally dependent question.
Okay, and then real quickly, I guess, or to end on a different note, Brian, any exciting innovations you're seeing in testing or innovation? I'm sorry, testing or mitigation?
Not so much on mitigation, but the availability and the quality of the measurement side of things has definitely gone up over the last 15 years, even in the last 10 years. There are a number of new continuous professional grade NRPP listed continuous radon monitors on the market that are very, very good. They have excellent support packages, but we often just don't have the budgets to have enough CRMs to do a large building situation, multifamily or otherwise. And what is the charcoal labs and the electret ion chamber labs have followed suit. They've dramatically increased their back-end support for large building testing. They're generating reporting outputs on your submitted tests that are much easier to read, much easier to use to make mitigation decisions. So quite frankly, the customer service aspect of the measurement industry has honestly come leaps and bounds, particularly in the last 5 years.
Okay, great. Thanks for that update. That's cool to get knowledge from the inside about, what's going on in the industry. There are a lot of questions related to what HUD requires. And again, we are not answering anything about HUD's requirements. If you're in a program, a HUD-assisted program that involves the MAP guide, you should definitely follow the MAP guide as well as any state requirements. Otherwise, HUD policy has not come out yet, so we're not going to discuss any implications from HUD policy. This webinar recording and materials will be available in a couple of weeks, and you will get a notification when that becomes available. And yeah, thank you everyone for joining. If we were not able to get to your question today. We will be providing a question and answer FAQ document in the slide materials when they become available. Thank you very much, and have a good rest of your afternoon.